key features of a function. This is example 2 with context. The graph below is used to model the suspension cables between the two towers from the Golden Gate Bridge in San Francisco, California. Architects and engineers need functions to model the design of the bridge to make sure it will provide the proper support and stability. The graph displays the height of the cables based on a given distance from the left tower. So again, in context problems, it is important to understand the scenario. So over here we have a picture of a bridge with suspension cables. So we have a tower. This would be the left side tower. This would be the right side tower. And then our suspension cable goes in between here. So we can see that the cable starts and stops at two specific locations. So this graph here helps us see that with numbers. But truly understanding the scenario is important. So identify the independent and dependent variable. So independent dependent. So thinking back at what independent and dependent means, dependent is what is changing because of something else. Independent is the piece that doesn't really change. It is the cause of the change, but it is not what is changing. So if we're thinking about here, we have the distance from the left tower. So we have the height and the distance from the left tower. So as we get taller, it's not the height is not changing the distance from the left tower. But as we go from starting from the left tower and we go to the right, the height is changing. It's coming down and then it goes back up. So we can think of that as the height is changing because I'm getting further away from the tower. We wouldn't say we're getting further away from the tower because the height is changing. That sentence just does not make sense. We can also look at the graph itself and we can look at the axes. When we have both the scenario and the actual axes, it's helpful. The distance from the left tower is the values down on the x-axis, which means that is your independent already. And then the height of the cable from the bridge surface is going to be your y values. So that is automatically your dependent variable. So our independent variable would be the distance from the left tower. And the dependent variable is going to be the height of the cable from the bridge surface. And again, using the graph to help us and looking at the axes can help us determine the independent and dependent variables. Okay, so our next question is, estimate the height of the cable when it is 150 feet from the left tower. So again, we want to think about what are we given and what do we need to find. So we want to estimate the height, so that is the y value. We want to know what y is when, and we're told 150 feet from the left tower. That is your x-axis. So we're told that x is equal to 150. So if we go and look at our graph, I'm going to use a blue highlighter. I'm going to go to 150 on the x, and I want to find the y value. So I go to 50, 100, 150 on the x, and I go up to the function. I have intersected the function, so then I come over to the y-axis, and I can see that on that y value, it's between 40 and 60, because it is counting by 20s over here. It's between 40 and 60, so maybe around 50. So we're going to go with roughly 50 feet above the bridge surface. Let me write that down. Approximately 50 feet above the bridge surface. The next question says, estimate the distance from the left tower. So this is going to be a little different. distance from the left tower, which is, we know that that is the x. We don't know the x. We want x when, and we're told that the cable is 100 feet above the bridge surface. So that's the height. 100 feet above the bridge surface is when y is equal to 100. So in this case, I'm going to use a green highlighter. I'm going to go to the y value of 100, and I want to find the x. So the y value of 100 is here. I'm going to go to the function, and then I've intercepted the function. Now I'm going to go down to the x-axis, and it is at 50 feet. Now this is 50 feet from the left tower. So our answer is approximately 50 feet from the left tower. We can also see that if we did 100 feet in the air, we can see that it would also be about 50 feet away from the right-hand side, which means from the left tower, we can see two different answers. We have this green highlighter comes all the way and crosses the graph again, and then we can see that it's about 450 feet away from the left tower as well. So we have two answers here. So we need to make sure we write both of those down. So it's about 50 feet and 400 feet. 450 feet from the left tower. There are two different locations at which it happens. So we need to make sure that we continue that green highlight all the way and intercept the graph as every time that it can. Our next question says, estimate the y-intercept and interpret the meaning of this in context of the problem. Again, the meaning is going to be about the actual bridge. So we want to find the y-intercept, and that's again when the graph is crossing the y-axis or when x is equal to 0. So if we go find x is equal to 0, we want to go and find the graph where it crosses the y-axis, which is roughly here. So that is approximately 0, comma, and I would say if that's about 140 in the middle, the y-intercept would probably be about 150. I would say about 150. So what does this mean? That when the distance from the left tower is 0, that means we are on the left tower. The height of the cable is at 150 feet in the air. That means that the cable starts at about 150 feet above the bridge's surface. Remember, y-intercept is generally the initial value. So we can say that the cable starts at about, because it wasn't exact, we don't have an equation, 150 feet above the bridge's surface. The next questions ask about the domain and range of the function, and then find the interval of the domain over which the height of the cable is increasing and decreasing. So let's focus on the domain first. The domain, as a reminder, is the x values of the graph, the function, the scenario. So if we think about the scenario, it is the distance from the left tower, it's the x's. So we know that the cable will start at the tower, and then it will in fact end at another tower. So that means that we have a start and a stop point. So thinking about that, our domain should have two values. So let's write out that we know that the cable starts and stops. Means that we will have two values for our domain. So we know we can put our x in the middle. We want to know, where does the cable start at? How many feet from the left tower? So we know that it will start on the tower itself. which will be a 0. But then where does the tower or the cable end? So the cable will end here, which is 500 feet away from the left tower. So it looks like there are 500 feet between towers. So the second number would be 500. Now our cable is between 0 and 500. So we know that 0 is the smallest, so 0 is smaller than x, but it will also be equal to, because it will be at the tower. It is allowed to be at the tower. And then the cable will go to the 500, but it'll be, everything else is smaller than the 500 feet, but it will end at the 500, so it is equal to. So our domain is 0 is less than or equal to x, which is less than or equal to 500. When it asks for the range is the y values, so we want to think about the height of the cable. So we know that the cable is not touching the bridge's surface, but it does have a stopping point as well, because it will go to the top of the tower where it starts at, and then it'll come down, and then it'll go back up. So we can see from this graph that the cable is not actually touching the bridge, and we know that the cables don't touch the bridge because that would be really bad for cars. So if we look at the range, because we don't have a function, we are actually going to use some estimates of the values because we can't see the exact values. So I'm going to use estimates of values. But we do know that the range is the y, and it does start and stop somewhere. So the lowest value, remember we always want to do the lowest value first of the y. So we have this minimum down here is approximately 25, because it's a little bit above 20. So I would say approximately 25 is the lowest point on the graph. And then the highest point on the graph, where it roughly started at, was at that 150. That's where the cables actually started at, roughly. So we'll say approximately 150. Now to fill in the inequalities, we know that all of the cable will be between the heights of 25 and 150. So we know that 25 is the smallest, so 25 is smaller than, and we will put the equals to sign because it can be at that height. And then y is going to be smaller than 150 feet, but it can be at the 150, so we'll put the equals to sign. So our range is 25 is less than or equal to y, which is less than or equal to 150. We're going to find the interval of the domain over which the height of the cable is increasing and decreasing. So we are focusing on the domain, so we will be using the number 0 until 500. So that's going to be our smallest number, and 500 will be our highest number. So if we look back at the graph, we can see, so from the start point of the y-intercept, we can see that the graph is going to decrease first, so it's going down, so it's decreasing first, and then it turns at that lowest point, and then it will start increasing. What that means is that it will decrease, and then it will increase. So let's make a little note about that real quick. So the graph goes down first, and then turns at the x of, so let's look at where it turned. So this location here, that coordinate is 250, comma, roughly 25. So at the x value of 250, so we'll say at the x of 250, that is the turning point of our graph. So as we write our intervals of increasing, decreasing, since it went down first, I'll actually write my decreasing interval first. So no, it's still going to be my x's. I can go ahead and put x's for both increasing and decreasing. And they will have a start and a stop point because it does start, it turns, it'll start again, and then it will finish. So since it decreased first, I'm going to do this one first. It started at the x value of 0, because that should be our smallest number. That should be our first number we write. And then it stopped decreasing, and it turned at the x value of 250, which is why we wrote this note. So I know that decreasing goes from 0 until 250. Now it'll be, all of my decreasing values are between 0 and 250, so it'll be 0 is less than x, which is less than 250. And I will not put the equals to sign on here because I'm going to make a note down here. This does not use the less than or equal to sign because it is not increasing or decreasing when turning. It's more kind of stationary. Now it also doesn't increase or decrease when it starts and stops. Just remember that as well. So anytime it is stationary, it's not increasing or decreasing. So if we go back to the graph, that was our decreasing location, our decreasing interval. Now it turned and now it's going to start increasing. So where did it start at? Again, it's that 250 and it went all the way until the end, which the x value was 500. So again, we want to make sure that our last number we write is that 500 because that's the domain. So it started increasing at that 250 and then it finished at 500. So we'll have 250 is less than x, which is less than 500. Again, no equals to symbol because it is not equal to, it's not increasing or decreasing at those turning points or where it starts or stops at.